This foldable is very straightforward. The ruler postulate and the segment addition postulate are both very straightforward, but this is the first time that you've seen the word postulate. And so we want to remember what the definition says. A postulate is a basic principle. You know, it's a statement that we accepted as true so that we could use it in other cases as a way to help define our arguments. So you'll see that this is very straightforward. There's not a whole lot to it, so it'll almost seem like it's confusing because it's so simple. So when you open up the ruler postulate, you can see the information here, and basically what you have to realize is that we're simply finding out the length or the distance between 2 points. Now it's called the ruler postulate because we're basically looking at the number line as if it were a ruler and figuring out how long that particular line is, or line segment actually, because of course the line goes on forever and ever, but this is a line segment. We have 2 points. We have point A and point B, and they each are identified with their coordinates, and we need those coordinates in order to figure out the distance. Well, you'll also note in the definition that the absolute value of the difference will give us the distance between those two things. And as we go through some examples, we'll see how that actually works. So let's look at this particular problem and identify the distance between those 2 points. So recognize that the distance is going along the x-axis because there is no y component here. We don't have to worry about the y values. They're both 1 in this case, and so there is no distance in the y direction. However, there is distance in the x direction. So we're simply going to say that the measure of AB, of line segment AB, is the absolute value of the location of B, the x value at B, which is 4, and we're going to subtract from that the x value of A. And when we do that, we end up with the absolute value of 6. And we know from before that whenever we take the absolute value of anything, we're just taking the positive value. So in this case, it's already positive. So the measure of AB is simply 6 units, whatever those units happen to be. So looking at example 1 for the ruler postulate, you'll notice that they're asking us to find out whether AB and CD are congruent to one another. So we have to remember congruent means equal to. So we have to look for the length of AB and the length of CD and see if they're the same. So in order to take the length of AB is going along the x-axis, so we're simply going to take the x values, subtract them from each other, and take the absolute value of that. And along CD, we're going to do the same thing, only that's going along the y-axis, so we're going to take the y values and subtract them from one another. So you do that, I'll do that, and I'll show you the answers in just a minute. So I've shown you the work here, and you can see that the length of AB is 5, and the length of CD is also 5. So notice that we can write that AB is congruent to CD. So let's do the same thing for example 2. I'll do the work, you do the work, and you can see what the answer is in just a minute. So here you see with these calculations for the length of AB and the length of CD, those two are not congruent because AB is 5 and CD is 4. Moving on to the segment addition postulate, again, these are very basic, but you really want to focus on the definition here. It says that if B is between A and C, then that means AB, which is this segment here, plus BC, which is that segment there, equals AC, which is this whole segment there. That seems very obvious, but a lot of times we'll forget those simple little things and we make it more difficult than what it needs to be when we have to answer a question like what we have to do on this practice. So let's clear this up and let's find BC. So if we simply use this equation, we know that AB equals 18. So we can put 18 in its place. Plus, we don't know what BC is, so we're going to simply put the placeholder for BC equals, and we know AC equals 30. So doing some simple mathematics, we subtract 18 from both sides, and we see that the measure of BC is actually equal to 12. So in example 3 and 4, we're going to do basically the same thing, only now we're going to have to apply some of our algebra. But the first thing we want to pay attention to is our definition. We want to note that the definition again is AB plus BC equals AC. So we'll use that equation to help us figure this out. So remember, we can substitute the value of AB, and in this case, notice that it's 4x. So we're going to substitute 4x in for AB. We notice that BC is actually 12x, so we're going to substitute 12x in there. And then we're going to say that that's all equal to AC, and we know that that's equal to 32 because it gave us that information. So when we have two like terms, we can combine them. 4x plus 12x is simply 16x equals 32. So now to find our value of x, we're going to divide by 16 on both sides. That gets us x equals 2. But that does not answer our question. We have to go back to the question, and it tells us to find BC. Well, remember, BC is actually 12x. Since x is equal to 2, we can substitute that in there, and now we find that BC equals 24. On example 4, I've already set the equation up for you because I substituted 14 in for AB. I substituted 3x minus 4 in for BC. And I substituted 4x plus 4 in for AC. So now take that equation and you solve it for x and then find the value of BC. So here's the work to solve for x. Now we simply have to substitute the value of 6 in for x. When we're looking for BC, we know that BC is 3x minus 4. So 3 times 6 minus 4, 18 minus 4 equals 14. And that's the answer to that one.